So we just ran a simple regression. Now let's run a multiple regression where we'll add more regressors or explanatory variables that hopefully will help us to improve this total R-squared, and that will help us to explain more variation in the total daily rates by members and non-members. So if we go to modify task, now we can add all of these new variables, except for this one, which is our dependent variable. So we'll add them to the explanatory variables. Everything's perfect here, so the options, we are gonna stick with them. No autoregressive model is needed for now. And the stats, we're going to keep it this way, the plots as well. The results, yes, we still want to have an output with the results that we can use later for the further analysis of the validation dataset. So let's say run, but instead of saying yes, we'll say no, because that will actually help us create a separate result output, and it will not overwrite the results that we had before on the simple regression model. So this is the result of our, or these are actually the results of our multiple regression model. We can see that now it's able to explain 76% of the variation in the total rates by both members and non-members. We can also see that all of the coefficients here are statistically significant, and we can see that let's say holiday is negatively correlated with the total member rights, so perhaps members don't write as often when it's a holiday. And let's say humidity again is negatively correlated as well with the total member and non-member rights. Well, the same goes for month. So I don't know why, but I mean this is like the way it is. So we also have these outputs, and we can see again the normality plot, and they're like normalish, but still they're skewed a little bit to the left, so that is not like perfect, you know, that's not exactly what we would like to see. Also we can see that we are still failing to predict our rates accurately, because we can see that residuals sometimes have like these this plot, the residual plot has long spikes, and that's not really good. And if you see the spikes here like in the negative, that means that you're over predicting rates, so you think that people would be writing like more often, and here you're under predicting their rates. And it's easy to understand why, because like if you look at our plot, right, actually it's really difficult to predict it, because it kind of like there is a trend, but the trend kind of like, you know, goes up first and then goes down, goes up and goes down. So there are a few turning points here. So let's see if our residuals are correlated. So if we look here at the Durbin-Watson statistic, we see this output. So we have to compare it to the table that I have here. We have an intercept, so that's why we actually have to look at this one, models with an intercept. And we have 6 regressors. Let's go back and I will show you. Here we have month, holiday, weekday, temperature, humidity, and instant. That's 6. So if we go, if we go here, our k equals to 6, and the number of observations, so this is the lower limit, this is the upper limit. So, and the number of observations that we have in our data set equals to 700 approximately, but the highest value here is 200, so we'll have just to stick to this. So the default hypothesis, or the null hypothesis, is actually that there is no correlation between the residuals, so the residuals are not correlated. And if our Durbin-Watson test, if our Durbin-Watson statistic is actually lower than this lower limit, that means that there is autocorrelation. So that means that we have to reject the null hypothesis. So let's go here and let's compare. So this one is 0.9737, which is actually less than 1.707. And that means that our residuals are correlated or autocorrelated. And that's actually not the best thing. That means that you will have a huge inflation in your forecast. Like all of these coefficients right now, they're not going to give you really accurate results, like when you try to forecast, because they are inflated. And as a result, you can be predicting a lot more rides, but in fact, you will need fewer bicycles. Maybe you will need even to close a few stations instead of adding more. So this is the consequence of relying on a model where we have the correlation between residuals, and that means that we actually have to work on that. So we have to remove that correlation, and then we can continue building the model.